Welcome. We'll discuss about the next experiment, that is experiment number 8. Write a program to obtain the linear convolution using circular convolution of the two given sequences. So here we have to use the linear convolution method. Here we have to calculate the linear convolution by using circular convolutions method. So this can be done with the help of one example. So let us discuss that one example first. So here we discuss linear convolution using circular convolutions method. So there could be the problem like this. There could be the example, that is, determine the linear convolution between the two given sequences. Let us say x1 of n is 1 and x2 of n is 1 to 1 using the circular convolution method. So we know that we can calculate the linear convolution directly by using the multiplication method as shown over here. So we are having x1 and x2 with two different lengths. Let us say the length of first sequence x1 is 2, the length of the second sequence is also 3. So here we have two sequences, two different lengths, and the linear convolution is of length of first sequence plus length of second sequence minus 1, so it is equal to 4. So we have discussed about this linear convolution and its method in unit number 2 in more detail that we have already gone through. So here I may say y of n is the convolution between x1 of n and x2 of n, and the star indicates it is a linear convolution, and that could be obtained by using this multiplication, or you may say the matrix method also. So this is just the linear convolution between the two sequences, and it is observed that the values are 1, 3, 3, 1. The same result can be obtained by using the circular convolution. So the above result can be obtained from the circular convolution by performing the n-point circular convolution between these two sequences. So we know that here I am interested in the n-point circular convolution, and that is equal to of length n1 plus n2 minus 1. So we need to calculate the 4-point circular convolution over here. So for that purpose, if you want to find out the circular convolution, we must have the two sequences are of equal length, that is x1 and x2, and as we have original sequence x1 as a 1 1 and x2 of n as a 1 to 1, we need to pad the number of zeros, and that appropriate padding 0 is shown over here. So x1 of n is equal to 1 1, and there are two zeros that are padded after the original sequence x1, that is capital N is minus n1, so capital N is 4, and capital N1 is 2, so 4 minus 2, there are two zeros that we need to pad in x1 of n. So my new x1 of n will be 1 1 0 0. Similarly, x2 of n is equal to 1 2 1. So again there is a single sample that is with 0. So capital N minus n2 is equal to 4 minus 3 is equal to 1. So there is a need of 1 0 in second sequence. So x1 and x2 are of same length, and here one can use the simplest method of circular convolution, that is the matrix method, and by using matrix method we have the output, that is y of n is equal to 1 3 3 1, which is same as that of the output of linear convolution 1 3 3 1. So let us verify this answers by using MATLAB. So here I have used the matrix method for the calculation of circular convolution on paper, but we can obtain the same result by using the DFT and IDFT method in MATLAB. So let us discuss the code for this in more detail in MATLAB. So in MATLAB, this is about the experiment number 8, that is we have to write the program to obtain the linear convolution by using the circular convolution of the two given sequences. So circular convolution can be obtained by the DFT and IDFT method as we have discussed in experiment number 7. So we'll use the same method over here also for finding the output of linear convolution. So here in line number 5 and line number 6, it is just an initialization of the MATLAB editor, then x1 and x2. So line number 7 and 8, here in line number 7 and line number 8 we have just entered the two time domain sequences, the first sequence x1 and second sequence x2. Then we have calculated the length of first sequence as a small n1 and length of second sequence as a small n2, and here we have just plotted these two sequences by making the subplot command. So subplot 3 1 1 stem of time axis for first sequence, that is from 0 to length of sequence minus 1 comma x1, and it is just with the field so that we can have the graph of first sequence with the circles, dotted circles at each samples plot. So here it is the title, subtitle, X label and Y label commands that we have gone through. Then similarly we have plotted the second sequence, that is by using stem command for X2. Now once we have the plot of these original signals, one can go with the zero padding. So that zero padding is depends upon the number of samples in the circular convolution that we are interested in. So capital, so here in this case small m is equal to length of first sequence plus length of second sequence minus 1. Here please be careful that this n, small n1 and n2 is the length of the sequences, n1 that is length of sequence x1 of n and x2 of n. So these are the notations that I have preferred over here, that is small n1 and n2. And then this small m is nothing but my capital N point circular convolution. So I have used small m over here for the circular convolution length. So x is equal to again zero padding, which is done with the help of simple commands. Instead of using that if and else loop, I have just preferred over here x is equal to the original sequence x1 followed by the number of zeros, and that number of zeros is equal to length of the circular convolution minus the length of original sequence. So that much number of zeros are padded at the end of each sequence. So x and y, that is line number 23 and line number 26, it indicates the zero padding, that is appropriate number of zeros are padded in each sequence, that is x1 and x2, in order to make its length equal to the length of the circular convolution that we are interested in. So as per DFT and IDFT method, I need to consider the DFT of first sequence, that is by using the command FFT of x comma m and FFT of y comma m. So x and y, these are the two sequences in terms of x1 and x2, but with the same length, that is with zero padding. So I have used the new variable, that is small x and small y for x1 of n and x2 of n. Likewise, so the FFT of first sequence is denoted with x underscore FFT of second sequence, that is x2, is denoted with y underscore FFT, and let us say the DFT of first sequence and second sequence is multiplied by point by point, and I can call it as a new variable, let us say DFT underscore xy. So by taking IDFT, one can have the output of the linear convolution by using the circular convolutions method, that is IDFT of DFT underscore xy comma m. So this will give me the output y, that is nothing but the result of linear convolution, that is by using the inbuilt command, that is CONV x1 comma x2. And next we have just plotted that circular convolution by using stem and plot command. So if I run this code, the in command window it is prompted me to enter the sequences. So I know that my original sequence x1 is 1 comma 1, the second sequence is 1 2 and 1. So if I enter it, we are having the circular convolution is equal to 1331. So that we have discussed in the PDF file. So it is equal to 1331. So this result is obtained from the circular convolution in MATLAB. So we will discuss this code one by one with line by line. So here I can comment the part of the code by making Control R in MATLAB. So here I am interested in line number 7, 8, 9 up to line number 20. So here line number 7, we have to enter the first sequence, we have to enter the second sequence, then we have to ensure the length of each sequence, that is n1 and n2, and then we need to plot the sequence x1 and x2 by making the subplot command. So we'll run this code, and if we come to the command window, it is prompting me to enter the first sequence. So my first sequence is 1 comma 1, and second sequence that I am interested in is 1 2 1. So it is observed that the length of first sequence is n2 and length of second sequence is small n2, it is equal to 3. So these are the sequences but with the unequal length, and we can plot them by using directly the by using directly the subplot command. So if I run this, if I enter the sequences 1 1 and 1 2 1, so we may have the plot of 2 two original sequences. So plot of first sequence I can call it as x1 of n, and plot of the second sequence I can call it as x2 of n. So once I know the x1 of n and x2 of n, the next task is I need to make the length of these two sequences equal to the length of the circular convolution in terms of linear one. So here I have used over here the zero padding directly. So line number 23 and line number 26, it gives me the zero padded sequence x1 and x2 in terms of variable small x and small y. So if I run the code and if I enter the sequence 1 1 and 1 2 1, then I am having the new sequence small x and small y, and that is with zero padding. So 1 1 0 0 and 1 2 1 0. It is nothing but in this case what we have discussed over here, 1 1 0 0 and 1 2 1 0. So if I come across the zero padding is over, the next task is I need to have the FFT of first sequence, FFT of second sequence. So I will just uncomment the next part of the code. So here I may say DFT of first sequence, DFT of second sequence, and the multiplication of first DFT with second DFT. So if I run this, come to the command window, enter the sequence 1 1 1 1 2 1. So FFT of first sequence, that is 1 1 0 0 is 2 1 minus 1j 0 1 plus 1j, and FFT of second sequence, that is y is equal to 1 2 1 0 is 4, then minus 2j 0 plus 2j. Now there is a point to point multiplication, that is x underscore FFT with y underscore FFT. It is nothing but 2 into 8, 2 into 4, so 8. So this is the multiplication, and this is the DFT of the first sequence multiplied by second sequence. Now if we find out its IDFT, that is nothing but the circular convolution, but it gives me the result of linear one. So I can compare this y1 and y2. So y1 is y and y2. Y is my circular convolution's result, and y1 is my linear convolution's result by using inbuilt command. But this y and y1 is nothing but the circular convolution in terms of linear, and y1 is the the command that is used to calculate the linear convolution. So y and y1 are the same. One is by using convolution command and one is by using circular convolution method. So again, if I enter the original sequence 1 1 and 1 2 1, it is observed that this y is the result of circular convolution and y1 is the result of linear convolution, but both are nothing but the linear convolutions. So here one can plot these linear convolutions by using the subplot command and stem command, as we have discussed every time in each code. So here I can have the subplot and the plot of circular convolution, but that is in terms of linear one, or I may say the linear convolution can be solved by using circular convolution. So that we have discussed in more detail at the class, you may say at the time of theory classes. So again, I can enter the original sequence 1 1, original sequence 1 2 1. So I am having the circular convolution 1 3 3 1 as a result of linear convolution, and linear convolution directly by using the CONV command, that is 1 3 3 1. So here we can have the plot of original sequence, that is x1 and x2, and the plot of linear convolution between the first sequence and second sequence, that is 1 3 3 1. So this is about the linear convolution using circular one. So thank you for attending this